in this lesson I'm going to talk about elements. Okay, so of course we want to define what is an element. Well, an element is one or more of the same atoms bonded together. Okay, so here I have examples of some elements. Now especially this lesson is targeted to grade 9 students, so you better be careful if you're a 9th grader. Okay, so as you can see, we have different elements with different chemical symbols and with their old names also on that side. So we're going to start first thing talking about those elements and what are their names and what does that mean, and then we'll go to the periodic table and talk about electronegativity and about the radius, and that's it. Okay, so as you can see, the first element here is antimony. Now antimony has the chemical symbol of Sp. So what does the chemical symbol mean? The chemical symbol is just simply, you can think about as the identity of the element, because if you say Sb, you will know that that's antimony, so that's the identity of antimony, it's always Sp. What about copper? Cu. Okay, so as you can see here, copper is Cu. Now we'll talk about the new names and the chemical symbols, then we're going to talk about their old names. What about gold? Au, iron, Fe, lead, Pb, mercury, Hg. Then we're going to go here, potassium K, silver Ag, sodium Na, tin is Sn, and tungsten is W. Okay, those are the chemical symbols and they symbolize each element. Now you should always be careful and always memorize them. Now it's a little bit easy to memorize them. You can think about antimony as Sb because a little bit those letters are a little bit easy to memorize. Sb, Sb, Sb. So it's easy to memorize, and as soon as you say antimony, just remember those two letters SMB, and that's it. You'll know antimony. Now copper, it's almost the same as it's almost the same as the chemical symbol. It starts with C, so you can think about copper. Okay, just Cu. Imagine you're saying copper. Okay, now what about gold? It's Au. Easy to remember because if you know silver is Ag, so the opposite of silver is Au, which is gold. Okay, we talked about how just to memorize them. Just try to give another similar image for that word, like antimony. Try to give an image that reminds you of Sb. Okay, now let's talk about their old names. Their old names, like antimony, is stibium, copper is coprum, and iron is ferm, and gold is going to be aurum. You can tell that from those names, you can tell that they're similar to their chemical symbol, because here you can see Sb is for antimony and stibium is old name, so you can feel it's like derived from the old name to make that chemical symbol. Coprum is copper, Cu. Au is gold, aurum. Fe is ferm, which is iron, and Pb is plumbum, which is for lead. And then we're going to have mercury. It's a little bit hard to pronounce. It's hydrargyrum, which is mercury. It's a little bit to what's called memorize and pronounce. What about potassium? Of course, it's K and it's called carium. Kalium. Okay, silver is Ag, argentum, and sodium Na. It's going to be natrium. Tin is Sn. It's going to be stannum, and tungsten, which is W. You can think about tungsten to memorize as wolf. Just remember the word wolf, and rum. Rum is for tungsten. Now those are the names and the old names of the elements. Now what about if we look at the periodic table? What do we talk about elements? Now we said that elements are defined from what? From their chemical symbol mostly, but the atomic number actually says what is that element. So if I say, what is the atomic number of, what is the element that has one proton? You say hydrogen, because that exactly identity of an element is always from its proton. So if I tell you what is the element that has two protons? There's no any other element that has two protons rather than helium. So that's how you can take the identity. Now let's go to the periodic table and just talk about electronegativity. Okay. So we want to talk about electronegativity, but before talking about it, we need to talk about small thing that you learn in chemistry when you're 9th grader, which is in the periodic table. So if we look at an image of a periodic table, right, I have here, just a second, you can see that we have those rows and rows and rows and rows and columns and rows. But what are they? Well, of course they have names. So I'll tell you. When you go down in the periodic table, you call that as a family or a group. When you go to the right, it is called as what? A period. Okay, going down or up is group, left or right is period. Now what is so good about that, or what is so good about learning about that? Well, what's helping us here is that if you look at the periodic table, always the group has almost the same chemical properties. What do I mean? For example, let's take group 2 in the periodic table, beryllium's group. We can see first thing that all group 2 have the valence electron of 2. So as much as we add shells and shells and shells, we can notice that we're left with 2 electrons in the outermost shell. So that's number 1. Always remember that every group have the same number of valence electrons. So if they're asking you in a quiz, how do we define like how our groups or the elements in a group are similar, you can say first thing they have the same number of valence electrons. Second thing, you can say that they almost share the same chemical properties. And another thing is that you should know about groups is that whenever you go down in a group, the shell will always increase. So you cannot go down in a group and you won't have your shell increasing. So you start, for example, from hydrogen, 1 shell, then you go to lithium, 2 shells, then you increase and increase and increase. Sodium increases by 3, it increases by 1 and by 1 by 1 by 1, and you can see that it will increase the number of shells. But what about the period? We said that groups, they have similar chemical properties, they share the same chemical properties, and they have 1 valence electron. What about periods? Okay, periods, well, they won't share the same chemical property, because you can see that each and every element, let's ignore that part, every element here has different valence electron. Okay, so what about periods? Well, periods, they tend to, whenever you have one period, they will always stay in constant number of shells. So if we stay, for example, in period 2, we'll always find 2 shells for that element, always. But of course, as soon as you go to the right, the shell will get smaller, or the atom will get smaller. Sorry, that's a bit vague. The atom will get smaller, smaller, and smaller. So that's that's an information about periods. Whenever you go to the right, the shell will decrease, or the radius will decrease. But as soon as you go down in a group, the radius will increase. Okay, let's talk about that. Now, we heard the term electronegativity, but what does electronegativity mean? Well, electronegativity means it's how bad an atom wants an electron. Okay, so if you have a bond between elements, the atom that has a higher electronegativity will pull that electron a little bit next to it. Another thing, if you're going to have an element that likes to react, and there's another element that doesn't like to react. An example, a noble gas like helium and halogen, fluorine. Fluorine likes to react always. And if we put helium next to it, it won't react. But the best example to give an example of electronegativity is about saying let's say oxygen and hydrogen. Now, oxygen has higher electronegativity. So when they bond with hydrogen, they tend to pull the electron because they want that electron. Don't mistaken that with another law, which is the ionization energy. Ionization energy is the amount of energy that it takes to pull an electron, but electronegativity, how bad it wants that electron. Okay, so what is the most electronegative element in the periodic table? You're right, it's fluorine. Okay, so that's about periods. Now let's look at it in another way. If I have a quiz and I'm telling you I have the element lithium, we have lithium, that's the first shell, that's the second shell. First thing, I want you to tell me what group is it in. You're going to tell me group 1. And if I ask you how do you know, you'll tell because I can see that lithium has one valence electron. So that means that always group 1 is the group that has one valence electron. But what about if I ask you which period is it in? Well, you're simply going to count 1 and 2. You have 2 shells. So does that mean it means it's in period 2? Okay, that's about groups and periods. Now we're going to have some exceptions like helium. Helium, how to know at which group it is in? Well, simply, this is helium. It has one shell. So what period is it in? You're right, it's in period 1. But what group is it in? If we're going to say that it has 2 valence electrons, it's going to be beryllium, but that's wrong. How do I know helium? It's an exception. Now helium, because it's a noble gas, you're going to have full octet level. You're going to have the valence electron fully filled with electrons. So what group has full valence electrons? You're right, noble gases. So that's how you identify elements and which group are they in. Now another thing we need to talk about is the radius. Always you measure the radius with a unit called the picometer. Okay. Now last point that we should all understand about is that if you get a quiz and they ask you about the atomic number, what is the atomic number? You can say that atomic number always identifies an element. Okay, so if I take for example oxygen, or let's make it in a better way, let's say I have 6 protons. What element will that be? You're right, 6 protons is carbon. But if I tell you I have 6 protons and that's oxygen, will you believe that? No. Why? Because we always say that the number of protons or the atomic number is the identity of the element. So this is going to be 8. Okay, so that's number 1. Number 2, you'll always have that question that says, what is the number of protons and electrons in an element? How can you do that? You can just simply look at the periodic table. You'll see that the smaller number is always to tend to be the it's going to be the atomic number. So the atomic number always represents the number of protons and electrons. Okay, so if I tell you I have oxygen, it has 8 protons and the atomic mass is 16. So how many protons and electrons does it have? Because I didn't give you any other sign that there's a negative or a positive sign, that means it's a neutral element. It's a neutral element. So how can I know how many protons and electrons do I have? Simply, I can see that I have 8. So if I have 8 here, 8 positive things, in math, 8 without any sign means positively charged. It's positive. And then, if I want to get the answer 0, because what does neutral mean? It means doesn't have a charge, so it should equal 0. What should I add to 8 to get 0? Or what can I subtract? You can say add, it's much better. What can I add to 8 to get 0? You're right, minus 8. And always, minus 8 represents negative. So you can think about the minus 8 are the electrons and the positive 8 are the protons. You add them together, you get 0. Another example. Let's say I have lithium. Okay, so lithium has the atomic number of 3 and the atomic mass of 7. So you can say, how many protons and electrons do we have? How can we do that? You're right. At first you look at the atomic number, it says 3. So I should always put the number that's the least, which is the atomic number. Always down, and it's always positive. Let's start with always positive. Then, I'll have to add it, for example, I'll have to add it now to get to a number that will equal to 0. And to know how many electrons do we have, it should always equal to that number to cancel it and get 0. So what can I add to 3 to get 0 and know that it's neutrally charged element? You're right, -3. So when I add -3, we'll get the net charge of 0. So that proves that we have 3 electrons and 3 protons. Okay, what about neutrons? Well, neutrons, it's the opposite thing. Which one of those represent the atomic mass? You're right, always the bigger number represents the atomic mass, and the lower number or the least number represents the atomic number. So here's the atomic mass. But how can we know that the number of neutrons? Simply use that formula. Atomic mass, okay, which is represented as A. Atomic mass is always represented as A, subtracted by the atomic number, which is represented as Z, and we're going to get the number of neutrons. Okay, so if I subtract 7 and 3, we'll get 4. That's the number of neutrons that are in lithium. We subtract 16 by 8, we're going to get 8. That's the number of neutrons in oxygen. So that's simply about the identification of the element, and plus also how can I know the number of protons and neutrons and electrons in an element. So that's all about our lesson for today, and I hope it is useful.